Therefore is equal to, next step is 1 by 4 e raised to 2t into e raised to 4t plus, just multiply both the terms, both the brackets, we get this term. Okay, now in each term base is same, that's why we have to add the indices, we get this term. Just add 40 plus 2t 60 and so on. Okay, now this is a simplified form of this earlier our example. Now taking Laplace, we have to find out Laplace on both sides. That's why take Laplace on both sides. We get Laplace of sine hyperbolic 2t into cos hyperbolic 4t, which is our LHS, is equal to 1 by 4 is a constant. Take outside and Laplace of each term. Okay, and this is a simple exponential form. That's why Laplace of what is Laplace of exponential? E raised to 60, 1 upon s opposite of this minus 6. E raised to minus 2t, 1 upon s plus 2t. Rest of the terms signs are as it is, e raised to 2t, 1 upon s minus 2, minus e raised to minus 60 is 1 upon s plus 6. Okay, this is the answer. Now we have to simplify accordingly. Okay, now here 1 upon 6 minus s minus 6, here s plus 6, and we have to add these two first and middle two first, because denominator is opposite in each other, terms are opposite in each other. Therefore cross multiply these two terms, we get s plus 6 minus, this is minus term, yes, plus minus 6 minus yes, and sign gets changed, plus 6, and this is addition only, plus this plus sign, multiplication, denominator is multiplication of two term, yes minus 2, and this is minus sign, that's why minus yes minus 2, and denominator is multiplication of these two. Okay, now simplify, yes gets cancelled, yes plus 6 plus is 12, and 2 gets cancelled, yes gets cancelled, minus 2 is minus 4. What is the denominator? A minus b into a plus b is a square minus b square, formula we have to use here. That's why it becomes s square minus 6 square, that is 36. And here s square minus 2 square, that is 4. Okay, this take this minus sign in the middle. Therefore take 4 outside and cancel with this 4. We get 3 upon s square minus 36 minus 1 upon s square minus 4. Now again, numerator contains constants only, that's why cross multiply, we get 3s square minus 12 minus s square plus 36. Okay, this is plus. Now add above this, this is just numerical. 3s square minus s square, 2s square minus 12 and plus 36, that is 4 to 24. Okay, now take 2 outside, denominator as it is, don't multiply these two terms. Okay, take 2 outside, to yes in the bracket term is s square minus 12. Okay, this is our answer. Okay, now these are two homework examples, in which the first example is of multiplication of cos hyperbolic function. Just follow this same step as earlier, and here cos one hyperbolic function, one cos normal function. Okay, this is the exponential property or first shifting property we have just studied. Now consider the next property, that is division by t property. Okay, what is the property? Let us see. Let f of t be any function such that L of f of t is equal to phi or in most of our properties we have this is the only first same step everywhere. Okay, let f of t be any function such that its Laplace is phi of s, then f of t divided by t, it is a division by t property, that's why t comes in the denominator, it just divided by t. Okay, that's why Laplace of f of t is numerator function, our original function, and we have to just divide it by t. And how we calculate the Laplace of such function? Where any function is divided by t, we get answer for this, or formula for this is integration. It is the basic integration s to infinity, limits are s to infinity, and this phi of s. What is this phi of s? This f of t is Laplace. What is this f of t? Just numerator, or whole numerator. Whatever the numerator in the example, we have to calculate the Laplace of first numerator of the term. Okay, and call it as phi of s. Then we can write directly Laplace of this function, division by t. What is that formula? We have to just take integration. What is that integration of? Integrand is phi of s, this phi of s. And limits, don't forget the limits, s to infinity. Okay. Now, before before going to examples, let us consider some mathematical formulas. Here are some mathematical formulas. We already know some of them. First, integration 1 upon x square plus a square formula is 1 upon a tan inverse x upon a. Okay, this is normal example in integration. Integration of f dash x upon fx. This is the formula where numerator denominator, there are two functions, and numerator contains denominator function's derivative. Okay, if such integrand is there, then value of this integration is, formula is log of this denominator, log of fx. Okay, now 1 upon infinity is always always have to remember, there is a definite term, that is 0. Log 1 is 0, 1 upon infinity is 0. Tan inverse infinity is pi by 2. Pi by 2 minus tan inverse x is its opposite, cot inverse x. Similarly, pi by 2 minus cot inverse is again tan inverse, both the way. But we are going to use this formula for more frequently. Now log, these are log properties. Log a plus log b becomes log a into b. Log a minus log b is log a upon b. Okay. Log a raised to b, if indice is there, okay, this b comes before log. Okay, b log a. Okay. Now consider the example, first example of this property. Find, question is same, that is find Laplace transform of following function. Okay, this is the 27th. As we have already know that we are continuing the number. Earlier example is homework example is 26 number, and we are continuing by 27th example. Okay, now we have to find out Laplace of sine t upon t. Here division by t occurs, that's why it is the example of division by t property. Okay, now we have to use that property. What is that? What that property says? We have to find out first numerator function's Laplace. What is the numerator? Sine t. That's why the first task is you have to find out Laplace of sine t and call it as f of s, phi of s. Here let f of t, we have to give the name for this function, that is f of t is equal to numerator sine t. First step, L of f of t, that is L of numerator, is equal to sine t Laplace is 1 upon s square plus this constant number square 1, which is equal to phi of s. We have to calculate as phi of s because property is like that. Okay, now directly by division property, this is the formula, you have to write down everywhere in the same in every example. Okay, L of f of t upon t is equal to, this is the formula, phi of s integration s to infinity phi of s ds. Put all these values in this equation, we get L of sine t upon t is equal to integration s to infinity phi of s is our 1 upon s square plus 1 ds. Okay, now what is this integration? This is the formula 1. Just write in the note 1 upon x square plus a square. What is a square here? 1 only. That's why put here in the formula x by s and a by 1. What is the answer for this? 1 upon a tan inverse x upon a. Therefore answer for this is 1 upon 1 tan inverse s by 1. S by 1 means yes. and put the limit everywhere, use the proper brackets, yes to infinity. Okay, 1 by 1 is 1, and put the upper limit in the first, tan inverse infinity minus lower limit. Lower limit is just put by yes only. Okay, tan inverse yes. Okay, what is tan inverse infinity? Pi by 2. This is, you have to mug up all these formulas. Tan inverse infinity is pi by 2. And what is pi by 2 minus tan inverse? Cot inverse. This is our answer for first example. Okay. Now second example. Laplace of e raised to minus at minus e raised to minus bt upon t. Okay. What we have to do first step? Let numerator be f of t. Let f of t is equal to e raised to minus at minus e raised to minus bt. The second step, we have to find out Laplace. Therefore, Laplace of f of t is e raised to Laplace 1 upon s plus a minus 1 upon s plus b. Okay. If minus is there, we are writing opposite of that. This is the formula only for Laplace of exponential. Call this as phi of s by according to the our division by t property. Okay. Now directly write down this property, pi property. Everywhere you have to write it. Huh? I'm just skipping some. I'll call it as, I'm skipping some formula writing step, but you have to write everywhere. Okay, by property 1 or by property division by t property, integration of f of t upon t means Laplace of e raised to this, our example, is equal to integration. This is the formula, s to infinity phi of s ds. Now put the value, integration as it is. Phi of s is, this is our phi of s. Put this, all this term in this integrand, we get into ds. Okay, instead of x it is s parameter or variable. Now this is 1 upon s plus a. What is the integration? This is log integration. 1 upon x integration is log x, or 1 upon x plus a integration is also log x plus a. What is that? Comes how it is, how it come from? It is integration of f dash x upon fx is there, then integration of such function is log of denominator. Here also in the denominator s plus a is there. What is the derivative of s plus a with respect to s? 1 only. Okay, a is a constant, derivative 0. That's why 1 is present in the numerator. That's why its the integration is log of denominator. Okay, now minus as it is, here also same function, the denominator derivative is in the numerator. That's why log of s plus b. Now use, here some adjustments are there, you have to see carefully. This is log term. If we put directly value infinity in this term, we get log infinity, which is not exist or it is not defined. That's why we have to do some adjustments here using log property. What is log a minus log b? It is log a upon b. That's why we are using that property here, log of s plus a upon s plus b. Okay. Now again in this step also, if we put infinity, we again get log infinity, which is again not defined term. That's why we again we have to do one adjustment, so that infinity, if infinity comes in the numerator, there is a problem. Okay, if infinity comes in denominator, examples get solved, because 1 upon infinity we know 0 can be answer for any example, but infinity cannot be answer for any example. Or as of now infinity we are not getting infinity, we should not getting infinity. That's why we have to do that adjustment such that infinity comes in the denominator. For that, here just in this expression only, in the numerator and denominator, divide the highest power of s. What is here highest power? 1 only, yes only. That's why from in the denominator and numerator divide by s. Within this numerator denominator only we can do that. That's why the rest of the term as it is, and divide this by yes, we get 1 plus a upon s, and same we have to divide by denominator also, 1 plus b upon s, right? And integration yes to infinity as it is. Now what happened? s comes in the denominator and we can easily solve this example. Have you understood all these things? Okay. Now put the limits, upper limit and lower limit. Upper limit is infinity. After putting infinity, what we get? This 1 up a upon infinity. Anything upon infinity is 0. Here comes 0. In the denominator, here comes 0. 1 plus 0 is 1 and 1 plus 0 is 1. And 1 upon 1 is 1. And what is log 1? Here answer is 0. Okay. Therefore, upper limit in every example in where we are using log adjustment, upper limit is only 1 log 1 everywhere, that is 0. Okay. Minus, what is lower limit? Yes. What we have to put? In the yes only we have to put yes. That's why the term becomes same as it is. That's why you don't need to write this adjusted term. You just write the original term here. Okay. This adjustment is for log 1. That's why instead of writing this term for lower limit, just write the original term for lower limit. Okay. Now next step, what is log 1? 0. Rest of the term as it is. Now we again know this is minus, means minus 1 is there. That's why we put it as minus 1 on the indice here. This is a property of Laplace log. 1 becomes behind the log. Okay. Now what is inverse means? Just opposite of this. Take numerator to the denominator, denominator to the numerator. We get inverse means s plus a, s plus b gets reverse, s plus b upon s plus a. Okay, this is the main example of division by t property. Okay, now consider 29th example. Laplace of cos AT minus cos BT upon t. This is the same example like earlier example, adjustment of log. Now consider the numerator f of t. Let f of t is equal to numerator cos AT minus cos BT. You have to find out Laplace of numerator. L of ft is equal to L of cos into L of cos bt. S upon s square plus this a square minus s upon s square plus b square. This is the original formula. Is equal to, call it as phi of s by using our division by t property. Therefore, by property 1 or by division property, L of ft upon t is equal to L of our original equation is equal to integration s to infinity phi of s into ds. This is the formula. Okay, put all these values here. We get integration s to infinity this phi of s as it is into ds. Now here what we have to do? See, in the denominator s square plus a square is there. If you calculate the derivative of denominator, what it comes? S square derivative is 2s. S square is a constant, s square derivative is 0. Therefore we have if you